That's just what we did. And this is for the final. There are 25 questions. We're going to do 2 tonight because we just covered this material. The function is f of x equals 4 to the x plus 2. And they actually did put a parenthesis around this x plus 2. Sometimes they leave it open there and don't put a parenthesis around it, but it's still a group. They want to know what the basic function is. So what is our basic function on this one?
4.
Y equals 4, and it'll have the x already in there. So 4 to the x. What does this inside shift do here?
To the left 2.
And what does this outside one do?
Down 2.
And they will want you to graph it. However, they give you choices. This is a multiple choice test. So A looks like that. B looks like that. C looks like that. And D looks like that. So which one is the closest?
B.
Why you should not sleep at random people's houses.
B.
Who's sleeping in random people's houses?
B,
That was totally
or D.
sorry.
The sleep option is not one of our choices here. We had to shift down 2. So it used to be up here at 1. So we shifted down 2, and then we shifted over 2. So it should be about right there. It should be the C. This one's not right because it would have shifted this way to the right, and we want to go left. This would be a shift to the left for our little change point right here, our focal point. This one's absolutely in the wrong place, and this one is too. So I think your answer is going to be C. But you can put it on your calculator. Just be sure you put all of this up in the exponent area and then this -2 below, and you'll get the right picture. Okay, let's do 22. It's a conversion. Convert to exponential form. And they give you log base 5, 125 equals t. And they want you to write it in exponential. And I've been doing this. I don't know if it helps or not, but it's the little base number. And remember, the answer to a log is an exponent equals the big log number. Little bitty number to the answer is the big log number. So this would be my answer. Any questions on that? Okay. So we've caught up with the problems that are on the final to where we are. Tonight's lesson does have some rules and some things that we'll need to go over. So let's start it. Any questions before we begin? This is section 9.5.
I'm sorry, Professor. Can you show that question? I had to go to the bathroom real quick. The number 22?
22? Yeah.
Yeah.
I can do it.
I just missed it. I had to step out for a second. Oh, okay. Piece of cake. Thanks.
It's a conversion. Okay. Any other questions? All right. So I'm going to write a note. I want you to write it down. Remember that logarithms are really exponents. So you're always looking for that little exponent to put it equal to the logarithm. That's what they are. And so the properties of logs are based on the properties of exponents. And the support class tonight will be working with exponents first, and then you'll move to logarithms because they're so similar. It's the same laws. Let's talk about the first law that we know. It's the product rule. And so when you're doing the exponent one, the product rule says a to the m times a to the n equals a to the m plus n. So if you had x to the third times x to the fourth, it would be x to the 3 plus 4, which is x to the 7th.
I remember this.
So logarithms are going to be just like that because they're kin. So if you have log base a of mn, that's equal to log base a of m plus log base a of n. So you split these two things up and write log base on each one of them, and you're adding them because, see, they were multiplied. They're multiplied, so you're adding the exponents. Remember, logarithms are exponents, so you're adding them. So let's see what that looks like. If you had log base 3 of 9 times 27, and they ask you to expand, this is called expanded form, then you would write log base 3 of 9 plus log base 3 of 27. That's called the product rule, and we use this one all the time. We use these rules all the time. We'll use them when we do tonight. Anybody need to wait before I move that information?
Almost finished with it.
Okay. It's called the
Okay.
product rule. If you multiply, product is multiplying two bases to the bases that are the same, you add the exponents.
Okay, I'm finished.
Okay. All right. The second one, the second rule that we're going to do is the power rule. And this one is used the most often. This is the one you really have to know. For exponents, it would be like a to the m all raised to the n power. Do you remember what we did to the exponents there?
You multiply them.
You multiply them, m times n. So if we had x squared and we raise that to the 4th power, that would be x to the 2 times 4, which would be x to the 8th. Called the power rule. Okay, let's see how that works with logarithms.
Do you only do it this way if it has a parentheses though, correct? Isn't there
Yes.
an exception on?
I usually call it parentheses to a power. That's what I
Okay.
usually call it, parentheses to a power.
Parentheses to a power. I'm gonna write that down. Thank you.
So if you have log base a of m and there's some power up here, p, this is the best one ever. You take this p and you bring it in front and it becomes a multiplier. You're multiplying it. So it's p times log a of m. Let's do an example of what that will look like. If you have log base a of 11 to the negative 3, your negative 3 is going to come out here in front, and you're going to have negative 3 times log a of 11, log base a of 11. Okay, see how you're multiplying these logs because they were exponents. This one you'll get to know. You won't have any problems learning it because we do it so much. Any questions on that? Okay, let's go to the third one, which is the quotient rule. This is going to be
Where you
do what? Yes, you're going to subtract, right?
subtract.
A to the m over a to the n equals a to the m minus n. Remember doing that? Now,
Yeah, I
this,
remember this.
this one right here may cause you some problems on the equation section, on the exponent section. This is x to the 7 minus 2, which is x to the 5th. However, be careful on this. You want, I was going to say always, but I think all of your assignments says always. You want positive exponents. So tonight, when you do this, if you have x to the 3rd over x to the 9th, you're still subtracting your exponents, but you want to put your answer where the larger exponent is. Put your answer where you have the larger exponent. You're still subtracting. You're subtracting the 9 and the 3. But where is the larger exponent?
9.
So 9 minus 3 is 6. Put it where the larger one is because there's more x's down here in the denominator. There's 9 of them than there is in the numerator. There's only 3. And remember, these always have a coefficient of 1. So if everything goes away in the top, your coefficient is still left up there, and it's 1. Coefficients are different than the exponents on these. So be careful on that. If you have more in the bottom than you do on the top, put your answer in the bottom and put a 1 in the top. Okay? All right, let's see what the quotient rule looks like for logarithms. The quotient rule for logarithms looks like this. Log base a of m over n. That's log base a of m minus log base a of n. Okay, so if we had log base 7 of 27/36, let's say. Looks like that. Then you're going to write that as log base 7 of 27 minus log base 7 of 36. That's the way you're going to write it. And you don't have to worry about the bigger one in this case. Your calculator will do it for you.
And then would we leave it like that, or we simplify it?
You will simplify it if it's possible. On the first ones, they'll ask you, they're just converting them. The first ones, they'll ask you to leave it, but we'll get to some tonight that you will have to simplify.
Okay, sorry, I'm jumping the gun over here.
Oh, that's okay. I like for you to think ahead. These are some nice handy things to put down in your notebook in case you run across it. If your base and your log number match, your answer's 1. That's because there's an understood 1 exponent up there. There's another one that says if you have a with the base and a is the log number and any exponent up there, it's going to be whatever that exponent is. This one is one that people forget all the time. Log base a of 1 equals. And the only way that you can raise a to a power to get 1 is if you're raising a to a 0 power. Okay. All right. How about this one? You have an exponent of a log A, and these A's match. So what's going to happen here is you get an X. This one right here we don't use very often, but when it comes in handy, it comes in handy. So if you have an exponent that says log base A of X, then your answer to this whole thing is just X. Okay, the other day we did this, but I want to remind you because you're going to need it today. If you have the cubed root of X, that's X to the 1/3. It's exponent over index. The index number is here. The exponent number is right there, and it's understood to be 1 for this one. If you have the 5th root of X to the 4th, you can convert that to exponential. Exponent is 4, index is 5. And let's talk about negative exponents. Some of you remember these, so let's talk about them. This section is not going to allow you to keep negative exponents. So if you have a negative exponent, I always circle mine so that I won't forget to move them. Move it to the other position. So this one is going to go down and this one's going to go up. So those are actually going to change places. So I'm going to have the X to the positive 5 on the top. It will change the sign on the exponent from negative to positive. And my X to the 3 will come down to the bottom. And it was in the numerator, and now I moved it to the bottom. So it's going to change that from a negative to a positive. Okay? Now, I'm not finished with this one. This one, I really do need to simplify before I go anywhere else with it. This one, I have 5 X's in the top and 3 X's in the bottom. So when I subtract them, I'm going to have X squared for my answer. 5 is in the top, so I don't have to worry about putting a 1 over something. Does that ring a bell from somewhere in your past? I hope.
Yes.
Okay. Any questions? Okay, let's go over this. I'm going to go over the exponential one first because some of these get a little tough, and I know from past experience that some of you are going to have some trouble with these. This is section 9.5, and those of you that are in the college algebra, just be patient one little bit, and before a few more minutes, I will be on the college algebra section of this that you probably want to stay for, at least the 9.5 part. Okay, so number 1 is multiply and simplify. It's easy. Don't make it hard. You can either change your exponent that's negative to the bottom, which is the common thing to do. Move it down to the bottom, and you'll have X cubed over X to the 4th. That moves that one down. And the 3 in the top is going to cancel into 4 of those in the bottom. You'll have 1 X left over in the bottom. And you have to put that 1 on the top because it's an understood coefficient up there. So be careful on that one. Okay. Any questions on that? Right, let's look at another one of those. Y to the negative 2, Y to the 8th, Y to the 7th. Okay. That's going to be Y to the 2nd's coming down, Y to the 8th's going to stay on the top, Y to the 7th's going to stay on the top. Now I have a Y to the 15th on the top and a Y to the 2nd on the bottom, which will make a Y to the 13th. And 15's bigger than 2, so there's not a 1 over it. That would be on the top, the numerator part. Number 3 is this rule that uses the powers. This one people miss because they forget to use their coefficients. There's actually a little number understood to be in those, that's 1. And that rule, that power rule, says to multiply those exponents if it's a parentheses to a power. So this would actually be 5 to the 4th, x to the 4th, 7 to the 2nd, x to the 2nd. Now I'm going to put my numbers together, 5 to the 4th, 7 to the 2nd, x to the 4th, x to the 2nd. You don't actually have to do that step, but it helps me. Now I put this on the calculator, and I found 5 to the 4th was 625, 7 to the 2nd is 49, 625 times 49 is 30,625, and I have an x to the 6th because I have to add those exponents there because you're multiplying bases that are the same. Questions? Okay, let's look at 4. Looks like that. Then there's a negative coefficient. Notice I can't move that to the bottom and get rid of a negative coefficient. I can only get rid of negative exponents. So what I have is 15 times negative 5. I have an a to the 10th and an a to the 8th and a b to the 3rd and a b to the 5th. So when I multiply these two things, I get negative 75, a to the 18th, b to the 8th. Good? Okay, they're going to start mixing them up. Negative 6x to the negative 3 times 6x to the negative 6. So I'm going to put my 6's together that are in the front. I have a negative 6 times 6. I have an x to the negative 3 and an x to the negative 6. So I have negative 36, x to the negative 9, if I add those two, or I can move them both down at that point. Now, I do have to move this down before I can write. This one doesn't go down. It's negative, but you can't change the sign on a coefficient. You can only change the sign on the exponent. Only change the sign on the exponent. You can't change it on the coefficient. So what I end up with is negative 36 over x to the 9th. Moving that 9 down changes the sign on that 9. Okay, have I lost you? Do you have questions?
I'm more concerned about the why as to how this kind of information would be applied to anything. Right now, to me, it just seems like learning rules and solving these problems for this specific problem on a piece of paper. It doesn't really have any application. I'm sorry.
Right.
I know exactly how to do it, but that's just where I'm at.
It doesn't have any application for you right now at all. It's practice. It's kind of learning the multiplication tables to be able to do multiplication problems. So that's where we are on this. This is basic exponents. You can't possibly be able to figure out what you need to do with this yet until we get into growth and decay problems. but you will need to use them. Now, I'll grant you that they don't give you very many of these to use. We are going to do on Tuesday a whole section of application problems, but there's not a lot of them to use that you have to do this process with. It mostly happens when you're doing in space, when you're doing very large numbers, then that happens. If you're in the depths of the ocean, it happens. Or if you have any practical problems that deal with population growth or decay or time of death, like I mentioned the other day, or any of those things, you'll have to do this. But this is like learning the multiplication tables in order to be able to do multiplication problems. This is the very basic elements of exponents. So you're right, you're not going to see an application on it. This is just practice. I'm sorry. I would give you the applications right now, but you might not could do them yet. Okay, let's do number 6. And I kind of like these because it helps me figure out, to me, it's always like a puzzle if I can get the right answer. If I can get the answer the author got, I'm in good shape. So I like these. 2 times 5 is 10. I'm going to put these out here. And we have y to the negative 11n and a y to the negative 13n. So 2 times 5 is 10. And if I add these together, I get 24. That's negative. And then this is negative, so I'm going to have to put it on the bottom. So y to the positive 24n. There's your answer. Okay, I have g to the 5th over g to the negative 7. That 7 is negative. I want to get it to be positive first if I can, and I can by moving it up. So I have g to the 12th. This one is 9x to the 9th, z to the 6th, over negative 3x to the 4th, z. 9 will go into 3 times. I don't have any negative exponents here, so I can probably figure this one out. Negative 3, 9's bigger than 4, so I'll have an x to the 5th. There's a z to the 1st down here, so I have a z to the 5th as well. Negative 3, x to the 5th, z to the 5th. If you can't figure out where I got something, please ask. 2x to the 7th, y to the 5th, and this is a parentheses to a power problem. The one that people miss on this one is they forget to include this 2. Don't forget 2 has its own exponent. So it's 2 to the 4th, x to the 28th, y to the 20th. 16x to the 28th, y to the 20th. It looks like 2 times 2 times 2 times 2 is 16. Okay. Let's do this number 10.
Wait, can you go back 1 second? I was finishing writing it. I'm sorry.
Sorry.
I can't see the bottom. Oh, there it goes. Okay. Okay, I got it. Thank you.
All right. Let's do this number 10. Negative 7 m to the negative 8 n to the 3rd p, and it's all to the negative 2. So this one's going to take a little bit of thought. 7 has a 1 on it, and this negative is affected by that as well. So it's negative 7 to the negative 2, m to the positive 16 when I multiply the negative 2 and the negative 8, n to the negative 6, and p to the negative 2, because this is a 1 up there. Okay, I'm going to change my negative exponents and move them. So I have the m to the 16th still on the top. The negative 7 is on the bottom, but now it's squared. The n goes to the bottom to the 6th power that's positive, and the p goes to the bottom to the 2nd power that's positive.
So anything that's negative, once it's underneath that line, it flips signs, correct?
Or if it's negative down here and it flips up to the top, it becomes positive.
Okay, thank
We'll
you.
have one of those in a minute too. So we have m to the 16th, and negative 7 times negative 7 is positive 49. So I have m to the 16th over 49, n to the 6th, p to the 2nd. That's a nice
So
little,
that's how they would like it. Like that's a simplified form.
that's it.
Okay.
So this one I have 4u to the 4th, v to the negative 5 over 5v to the negative 6. And they're going to raise this one to the positive 2 power. So I have 4 to the 2nd, u to the 8th, v to the negative 10th, over 5 to the 2nd, v to the negative 12th. So I have a couple here that I need to change the places on them, moving the 10 down and the 12 up. I'm going to go ahead and multiply these out. 16 u to the 8th, and I'm going to move my v to the 12th to the top. 25, no u's down there, but I've got a v to the 10th that's going to come down there because it was negative in the top. Now I've got v's that are the same, so I'm going to have 16u to the 8th, v to the 2nd over 25. Did I lose somebody on that one?
Hold on 1 second.
Are one
Okay.
of these going to be on the final?
Do what?
Are one of these going to be on the final?
I can't say for sure.
Oh, okay.
They usually put one of these like this on the final. And I
Can
don't
you,
remember, have we gotten one yet? I don't think we've gotten one yet, have we?
No, we don't have one yet. That's why I was asking.
and can we scoot that down just a little bit?
Right there.
Okay. Uh-huh, that's fine.
Hang on a second and I'll look. No, they do this section with logs instead of with exponents.
Okay.
It's the same rules. Okay, can I move this now? Maybe.
Yes.
All right, let's look at 12. We have a negative 7 to the 5th, x to the 2nd, y to the negative 2, over 5 to the negative 4, x to the negative 3, y to the 3rd. I think that reason is because they've tested you on this already from doing, if you were in a class earlier, like a developmental class, they've already tested this. So this is going to be negative 7 to the 10th, x to the 4th, y to the negative 4, over 5 to the negative 8, x to the negative 6, y to the positive 6. When the numbers get big like this, they leave them alone except for changing the sign. The sign changes because 10 is an even power. It's just like if I raised negative 7 to the 2nd power, it would be positive 49. Anytime I raise a negative number to an even power, it will make the whole value positive. So they will write that as 7 to the 10th power. And your x to the 4th is up there, but my x to the 6th is going to have to come up. And my 5 has got to come up, doesn't it? 5 to the 8th has got to come up. And in the bottom, I have this 4 that's got to go down there. Y to the 4th and y to the 6th.
And then you just combine the like terms.
Yeah, and because the exponents are big, they
Would
are.
you multiply those out and then add them?
No, I wouldn't do anything with them. I'd leave them just like that. Once they
Okay,
get
so if we leave
huge,
it like
huge
this, it'll-
numbers, they leave them in this form.
Okay, so that can be considered simplified.
Mhm. If
Okay.
it's anything that's over about 4 or 5, they'll just leave them as exponents. Okay, that's the last of those kind. There's 2 that they're going to do that's asking you to simplify with having to factor. So they're not going to let you get away from factoring yet. You have to factor this one into s plus 1, s minus 1. And this one in the bottom, this is number 13. It factors into s minus 1 and s minus 1. So these 2 would cancel. And our answer would be s plus 1 over s minus 1. And you can't take these out. These are groups, so you can't just slash out those s's in there. That won't work. That's going to be your answer.
We have to put parentheses around it, like just like this.
No, you don't have to. If it's in the
Okay.
top or bottom of a fraction, it's always considered a group.
Okay, I know Blackboard's like got their own uniform
Uh-huh.
way of thinking. So I was just wondering.
It's considered to be a group if it's in the top of a fraction or a bottom of the fraction. This one will factor into s plus s minus 4 and s plus 4. And in the bottom, it factors into s plus 9, s minus 4. So it looks like your s minus 4s will cancel, and you'll have s plus 4 over s plus 9. And that is the last problem of that support group section there on exponents. And normally I don't always go over the support group ones, but tonight we had to do these rules. And sometimes you get those negative exponents all mixed up. Okay, let's do the logarithm part. This is the part that will be on the test, actually. So this is section 9.5, but it's the logarithm part. Number 1, you have log base 3 of 3 times 9, and they want you to expand it. So these are multiplied. So back on our rule, the product rule, we would say that's log base 3 of 3 plus, because it's multiplied, log base 3 of 9. Now, I'm not going to simplify yet. In a minute, they will say, and simplify. If they don't say, and simplify, they just say, and expand, or to express as a sum, and sometimes they do it that way, then don't worry about simplifying them. Number 2.
So expand it, like leave it as is, basically.
Yes, leave it just like it is, unless it says
Okay.
the word simplify.
Okay.
So this is LNB. Notice don't put the E on there, plus LNC. They don't like for you to put the E down there, even though it's the understood base. And again, because they're multiplied, you add those logarithms. Number 3 is log base M of t to the 11th. And they want you to do something with that. It says use the product rule. Remember, the product rule is where you take this 11 exponent and bring it down in front. So that's what you want to do. Looks like that. And again, this is just exercise, just like those others are. We will learn to put these into some practical problems on Tuesday, some of them. Okay, this one says ln of the fourth root of 3. I'm going to rewrite that as ln of 3 to the 1/4 using that exponent over index rule. And then I bring my exponent to the front, which would be 1/4 ln 3. Okay. Number 5 is a difference, so we have log base b of d over 4. That's a quotient. I'm going to use the quotient rule. Okay. Let's see, that's going to be log base b of d minus log base b of 4. That's subtracting them. Okay. On this one, you might want to see if you can do it before I do it. See if you can get it right, and I'll ask someone if you've got it.
Is it ln v minus ln t?
No, that's it. Okay, let's try this one. Log base d of x to the 6th, y to the 7th, z. Okay, so first step, you want to write these as sums. So log base d of x to the 6th plus log base d of y to the 7th plus log base d of z. Now you're not finished until you bring these exponents out in the front. So this one will be 6 log base d of x plus 7 log base d of y. This one has a 1, but I don't have to put a 1 in front of it. I can just leave that one alone. Okay, we're doing good. Okay, let's do a few more of these. Number 8.
Can you put that back up? I'm almost
Yeah.
finished. I was almost done. Let's see. Okay.
Okay, we good?
Mm-hmm.
All right, let's try number 8. I'll just put it on here. It's log base b of p to the 3rd, q to the 7th, over m to the 4th, b to the 9th. So I'm going to have to break that up into all those parts. Log base b of p cubed, and these are in the top and they're added because they're multiplied, plus log base b of q to the 7th. Now, once you get down here, you subtract anything that's in the bottom because then it applies the quotient rule. So it's minus log base b of m to the fourth minus again, because this one's in the bottom as well, log base b of b to the ninth. Now then you can pull your exponents to the front. This one will come to the front, and you'll have 3 log base b of p plus 7 log base b of q minus 4 log base b of m minus 9 log base b of b. This is the very first one that we have a place that we can reduce our problem. This one down here, because the b that's in the base matches the big B log number, those two cancel because this part of it's just 1. 1 times 9 is 9. So that one you can change to minus 9 on the end. The others you can't do that because it's a different base than the log number.
Okay, you said, how would that cancel out? You
Because
said,
this B here that's in the
Mhm.
base and this B that's the big log number are the same. This exponent up here is 1. Remember that rule that we had that said if those match, then your exponent is your answer? Do you remember looking at that one? It was back on our rules, this one. When the log and the log number match, the base and the log number match, the answer is just what the exponent is. So if you
Okay.
have the two A's together, it's an understood 1 up here, so it's a 1. And then 1 times that 9 that's in the front is just 9 there. Now these are still on there. I just didn't rewrite them. This is the only one that changes. Okay, let's look at number 9. Number 9 is ln 6 over 7x to the 7th y. This one's not too bad. Somebody work on it and see if you can get it. See if you get the answer. Okay, let's see what it looks like. It's ln 6 minus ln 7 minus ln x to the 7th minus ln y. And I subtracted all 3 of those that were on the bottom. You can't put these two together. They've got to be separated. So ln 6 minus ln 7 minus 7 ln x minus ln y. Do you know where that third one got that 7 that was in front of it? Anybody get it?
Yeah, I got it, but the homework doesn't phrase it like that.
What do you mean?
Oh, never mind. I didn't just look at your answer.
Oh, okay. You change your mind, it does phrase it like that?
Well, it's the middle part where the ln 7 minus 7 ln.
Uh-huh.
Yeah.
You have to bring the 7 in front on that one. The others don't have exponents. Okay, number 10, log. We have a square root of a c to the 9th and a d here. So let's do this one. Let's change that x to the exponent over index business. So c would be to the 9/2, and d would be the 1/2, because a square root has an understood index of 2, and d has a little exponent of 1. So we would do exponent over index, which would make 9/2. Exponent over index would make 1/2 on the d. Okay, now we're going to expand it. Log base c of 9/2 plus log, not base c, log c. That's not a base, guys. Here, let me do that again. Log c, it's a base 10. It's not, they don't have the base written on there. Plus log base 10 of d to the 1/2. That understood base on log is 10. It's just not written there. Now bring your exponents in front, and you'll have 9/2 log c plus 1/2 log d. Okay, this number 11 is a stinker. Let's see. I'll give a point to the first person that gets this one right. How's that? An extra point. I'll do it. We have log base b of the 4th root, and the root goes over this whole thing, the top and the bottom, of m to the 12th, n to the 8th, b, that's b, b to the 7th, c to the 3rd. Let's see if you get it.
Is it log b 12 over 4?
Well, that's
Uh,
going to be the first step.
Is that one of the, is that am I going the right direction?
Log base b of m to the 12 over 4, n to the 8 over 4, b to the 7 over 4, and c to the 3 over 4. That's the first step.
And then you would subtract, is that right? Because it's a quotient.
These right here you subtract. What do you do with these up here?
You add them.
Oh, come on, man. Don't give it to her. I'm almost done with it.
Okay, I'm just going to write the first step.
I was just wondering if I was in the right direction. I'm overthinking it like usual.
There's your first step. Let me get my point sheet out here. Somebody's going to have it here in a second.
You can give it to her. I don't know the distributive property of logarithms outside.
There's not a
of-
distributive property for logarithms.
Oh, never mind. I got it. Oh, yeah, I got it.
What'd you get?
I got, okay, so it's going to be log A
There's no A
top
on
line, log A,
There's
top
no,
line.
there's no A on here.
Is a B.
Oh, it is a B. Oh, wow. I did my homework, not yours. I'm stupid. Man, hold
You
on.
did the one
Go
on your
ahead.
screen,
Yeah.
Hans, and my
I brought the
screen.
problem up on my screen, so I did
Yeah.
my screen, not yours. Sorry.
That's all right. I guess you won't get that point, will you?
No, I don't.
Is a
It'll
log.
take too long to give you the answer.
Okay. Somebody got it?
It worked on my homework.
It's log M of 20/4, mn 20/4.
Nope.
No.
Is it 3 log of BM
That's
plus
that's plus what?
2 log of BN
Okay. That's 2 you've got right.
minus 7/4 log BB minus 3/4 log BC.
Okay, you almost have it right. You have one tiny mistake.
The B's are the same.
Uh-huh. So what is your answer for that part?
Would it be 7/4?
Uh-huh. 7/4. Amanda, you got it. Did anybody else get it? Let's go from here. We've got log base B of M to the 12/4, which be the third, N to the second, B to the 7/4 won't reduce, and neither will the 3/4. So then we expand it. Log base B of M to the third plus, these two are plus because they're on the top. The bottom ones you subtract, plus log base B of N to the second minus log base B of B to the 7/4 minus again log base B of C to the 3/4. Now bring all those exponents out in front and you get 3 log base B of M, 2 log base B of N. These two are going to cancel. See these two B's here? That's going to make that thing go to 1. And 1 times 7/4 is 7/4 minus log base B of 3/4 log base B of C. Bring your 3/4 out in front. So this one is the only one that canceled anything because you have the base and the log number the same. So that makes 1. 1 times 7/4 is 7/4.
Okay, is that? Yeah, I couldn't see it that well.
So 7/4 is by itself? Is that
Yes.
okay?
I'm still writing this down because honestly, like, I feel like I'm just copying this down and I don't know why I'm doing what I'm doing.
Okay, are you understanding that because these are multiplied, you add them from that log
Yes.
we talked about?
Yeah,
And because
remember
they're in the
that.
bottom, we're subtracting them. That's from that
Right.
quotient rule. And then after we get it in this expanded form, we're bringing all of these exponents to the front.
Right. I know that part. I think I just didn't.
And the reason this one only ended up being the 7/4 is because this log base B of B cancels. It goes to 1. It's one of those rules.
I think they're the same way with you, Chandra, because I feel like my brain hasn't processed the formula for it yet. Like
Right.
it's just I'm just writing it down and trying to understand what everybody else is doing.
Right. So let's see.
Believe me, you ain't the only one. I'm struggling. The further we go,
Well, part of the problem is you've only practiced this a few times. This is number 11, and each one of them are a bit different. But you haven't practiced. See, this is new learning for some of you. You haven't done this before. It's a practice thing. Okay, let's look at number 12. I'm going to move on to the next section in just a minute, but let's look at some of these others for this section. This is number 12. It actually changes a little bit. This one you're going to write as a single logarithm. So it's in the expanded form now. So you're going to go backwards. See how that's in the expanded form because of the plus here?
I don't want to do this shit. I feel like an idiot.
Your mic's on, man. It's okay. It's okay. Just
Sorry.
But don't feel like an idiot because we all in the same boat.
Because like math,
It's
like if
okay.
I'm not careful, I will bust out crying. Like I'm not playing.
Well, you know what, guys? We are almost through with this course. And if you can just handle this section, then probably you'll be home free because we're going to be doing matrices next week. And all of you have a calculator and you already know how to do matrices. So
It's like on the Super Mario Brothers. It's like you make through you pass all the worlds, and then you get to the dungeon. Yeah, that's how.
You can't take King Cooper out.
Right.
yeah, this is kind of the dungeon. You're right. Okay, now go back to that rule that we had where we were adding those logarithms because the logarithms were multiplying. Do y'all remember that rule? We talked about it at the very beginning of this section. It was called the product rule. Here it is. Remember this one? If you had these two multiplied, you split them up like this. That's what we've been doing. Now we're going to go backwards, and we're going to take this and go backwards with it. So let's look at this. If they're added, then these two log numbers should have been multiplied. So you're going to do 21 times 25. And whatever that is your answer. So when you put them back together, going from expanded form to this is called contracted form, then it's a lot easier. And I understand, guys, that y'all don't get quite as excited about this as I do. It's all right. I've lived with this for a long time in my life.
I was way more excited with the synthetic division. Especially when I found out it was going to be a 0. I was like, yes, it's a 0.
Wonder what that is. Can you do that on your calculator?
I think it's 2.
Mm-hmm. Log of 100, the base is understood to be 10. So that answer is 2. Okay, let's try this one.
So this is basically the opposite. Instead of
This is
expanding,
the opposite. It's going backwards. Sometimes
Okay,
it's
that's what I'll-
easier to go backwards than it is to go forward.
Yeah.
That's the story of my life for going backwards.
Okay, this is the last one we're going to do this kind, and then we'll skip to the other one. All right, this has got to come back over here at some point, and this has got to come back over here as an exponent at some point. And this one's got to come back over here as an exponent of some point because there's numbers in the front. So that's my second step. I'm going to write log base b of x to the 1/4. And then this one's going to be log base b of y to the 2nd. I'm going to move that one back. Minus log base b of x to the 4th. I'm going to move that 4 back. Everybody okay with that?
I'll get this a little bit better than the other.
Good. Okay, now then, because these two are added, they're going to be on the top. And because this one is subtracted, it's going to be on the bottom. You understand that part?
Mm-hmm.
So I'm going to write this as log base b, and I'm going to put these things that are on the top, and the thing that's on the bottom, so that it looks like that. Okay, now then, I'm home free, except that I have bases that are the same here. X to the 4th and x to the 1/4. So this may not be so easy. You may have to do it on your calculator if you don't know how to do it. But I have an x to the 1/4 on the top and an x to the 4th on the bottom. And I need to get these bases the same. 4 is bigger, so I'm going to leave the y squared up there. It's already up there. And I'm going to do x to the 4th minus 1/4. Now, somebody do that on your calculator or do it in your head or somehow tell me what 4 minus 1/4 is going to be, so I'll know what that number is that goes up there.
7/4.
3.75.
Okay, change it to a fraction.
7/4.
3 3
How many?
3
7/4.
7/4. I don't think's right, is it?
4 minus 1/4.
4 minus
Oh,
a
my bad.
quarter would be-
15. Sorry.
Okay, 15/4, isn't it?
Yeah.
Okay, so it's y to the 2nd over x to the 15/4. Okay, so what we did was go backwards. We made these our little exponents. And because these were added, we multiplied them and they were on the top. If it's subtracted, it comes down to the bottom. So the x to the 4th came down here.
I can't see that part. Okay, yeah, there we go. Okay.
So 4 minus 1/4 is 15/4. Okay. There are actually 17 problems, but hopefully you can do those last 3. If you can't, give me a call and I'll help you with them. Or you can look online. These notes are online already. Anyone else need to still see this section on this 14? Okay, let's go to 9.6. And 9.6, we've already discussed how to do, but there's going to be one exception to what we've done, and I'll show you how to do it. We did these problems the other day. The secret was to get the same base. And all these problems say solve. So the base is 3. I can see that right there. Is there anything I can raise 3 to get 81? 3 times 3 is
9,
9 times 3 is 27
27,
times 3 is
81.
81. So that would be 4
It's to
times,
the
wouldn't it?
fourth power.
So once your bases are the same, you can cancel those bases out. Once you got them the same, and set your exponents equal. Do you remember doing this the other day? We did these problems. We went ahead and did them this way, so because I knew you were going to run into that in this section. I was trying to save a little bit of time. Okay, this is the same question. Can I raise 6, is my base here, to some power to get 216?
To the third.
Now, once your bases are the same, then set your exponents equal. So x is 3/7. Okay. Let's try number 3. Number 3, you need to put a star on. You're going to have one like this on the test. You have 3 to the x equals 24. Can you raise 3 to some power to get 24? Three times 3 is 9. Times 3 is 27, not 24. So when you can't get the same base, then what you do is log both sides. If it has an E on it somewhere, you'd LN both sides. But we're going to LOG both sides. So I'm going to say log 3 to the x equals log 24.
That's it.
Well, no, we have to solve it for x.
Oh,
So this
okay.
little x is going to come down in the front. X, that's from what we just did a bunch of. Okay, now remember log 3 is just a number. So I'm going to divide out log 3. I'm just trying to save myself some time so that I won't have to spend so much time in the calculator. All right, now then I grab my calculator, and this one, they will say to 4 decimal places. So grab your calculator and see, we're moving to equations because we're getting ready to do some application problems, but we had to learn those rules first. So I want to do log on my calculator, log 24 divided by, and don't forget to close the parentheses. Remember the other day when we were doing that, you have to close your parentheses, divided by log 3. What did you get?
Two point 892.7.
Is it 2.8?
Yeah.
2.892.
2.8074, is that what you get?
No, ma'am.
No.
2.8928.
Up. 2.8928. Okay.
When I was doing my homework and I was trying to put it in, it was making me put in what I actually got on the calculator, not rounded up or down. Not rounded up or down. So, which one is the computer going to except
A computer is only going to accept this number right here. It won't accept this. You have to have an actual number in there.
no, I put in like, okay, when we looked it up, it didn't round up. I mean, the computer wouldn't take it when I rounded it up like 2.8927, and everybody else got 2.8928. It wouldn't take that 8 for me. I would have to put that 7 in. So I don't know.
All right. Do you see this, all this number here? Or does
Yes,
you see all this number?
I do.
Okay.
And when I put it to the fifth, and
Okay, well, you have to round this by hand. The 7 is the 4th digit, but the digit behind it is 8. So that means you're going to take that 7 to an 8.
well, exactly. And that when I try to put the rounded up number in the computer, it wouldn't take it. It would only take it as it was in a computer. I mean, as it was in a calculator. So that kind of confused me earlier when I was doing my homework.
It wanted this whole number?
No, it just wanted the 4 numbers after the decimal. But like when you guys rounded it up to the 8 instead of the 7,
Right.
it only took it for me if I put the 7.
Really? Well, that's an error. Next time that happens, send that to me because that's an error.
Okay.
Tell me which one it is because I need to look at that one. Send me a picture of it because that's an error. And we found an error 2 years ago or so. Maybe it's last spring. We found an error in one of the answers. So that's an error if that one did that for you. So send that to me and let me look at it. I sent a note last time to the people in charge of that program and they fixed it. All right, let's do this number 4. We have 3 to the 6x minus 1 equals 81. And so now we're back down to doing this with the same base. So 3 to the 6x minus 1. And what did we say 81 was?
To the 4th.
To the 4th. Okay, once your bases are the same, you can set your exponents equal. And we'll have a 6x equals 5 or x equals 5/6. Okay, let's do number 5. It's 2 to the x equals 7. And I know that I can't raise 2 to a power to get 7. So what I want to do is log both sides. So log of 2 to the x equals log of 7. And again, I have to bring this x in front. Now this time, Sequoia, see if you get it. X log 2 equals log 7. So divide both sides by log 2 and put it in your calculator. And this is supposed to be 2.8074. See if you get that number, Sequoia.
Yeah, that's what I got.
Okay, good. All right, let's try 6. 6 is a little bit harder. These will get harder as we go. 10 to the negative x equals 4 to the 3x. Those are very different bases. So I'm going to log both sides. Then I'm going to bring my exponents to the front. So I have negative x log 10 equals 3x log 4. All right. Now then, I have X's on both sides. We need to get them on the same side. Okay. See, I have an X here and an X here. So what I'm going to do is I'm going to subtract this 3x log 4 off of here. And I have a 0 over here because those two cancel. Okay, now then, what I want you to do now is let's figure out what these numbers are. What is log 10 in your calculator?
2.
2? Should be 2.
I got 1.
Should be 1. Log 10 should be 1. So 1 times negative x is
I'll take
negative
it from
1x.
my bad.
Okay, so I have negative 1x minus 3x log 4 is what I've got when I change that to a 1. What is log 4? Somebody put in log 4 in your calculator.
0.6020. No, 21.
6021. Okay. Now then, that's log 4. Let's multiply it times this 3x here and see what we get. What's 3 times 6.021? So this is really 1.8062. Is that what you got? So this is this, but this is multiplied by this and this. So then I'm going to take my 3 and multiply these two numbers. So I got 3 times 0.6021 is this. And this is the x that was there. I haven't changed it. It's still the x. Now then I need to know what negative 1 and negative 1.8062 is. That's negative 2.8062 if I added right. So then I divide this out. And guess what my answer is?
Okay, I didn't get what you were saying. So once you multiply the 3x times the 0.6021, what
Yeah.
happens after that?
See, this is a number and this is a number. This number is 0.6021.
So we're distributing that?
And so you're not distributing it, it's just multiplying. It's like 3 times x times 6. It's just
Right.
like that. That'd be 18x.
Right.
So it's just like that. It's this number times the 3, which is 1.8062. And the x is still sitting there. It's still multiplied.
Okay, because I got confused. I'm like, what? Okay, I get it.
Now then, these two combine because they're both x's. It's like combining a negative 1x and a negative 1.08x or something like that.
Right.
It's still just combine them. And you get negative
So after all that, you're telling me x is
2.8062.
0.
Do what? You did all that to get x equals
You're
0.
telling me after all that, tell me x is 0? I'm sad.
Well, in a minute, they're going to do one that the x is not 0. So
Oh, of course.
they just let you do this one for practice.
Mm-hmm.
Okay, let's do number 7. We're going to move from LOGs to E's, which would be an LN situation. Okay, let's do this. I'm going to do ln of e to the t equals ln 165. I'm ln'ing it. You know why?
The E.
Because you got the E.
because it has an E on it. That's right. So now this T is going to come down in the front, just like the exponents always do at this point. We're getting used to doing that now. We've done a few of them, so that's what's happening. So
I can't see that. 1 second. It's like blurry. Might just be me though.
is it still blurry?
I think it's just me. It's by my connection.
So now I have T ln E equals ln 165. What is ln E? Somebody do that on your calculator. What is ln E?
One.
1. ln E is 1. So now I have 1, 2 equals ln 165. So what if I can figure out what ln 165 is, I'm in good shape.
The answer is
5.505.
Would you rather
Decimal places, is it 5.9?
Oh, you're right. I'm sorry.
Okay. Let's do, it's almost time for class to be over. So I'm going to stop here with 7 and I'm going to skip down to 13. And if you want to stay with me, I'll do the others in this section if you want to stay. But this will be the last one we do as the regular class, is 13. We've got LOGX plus LOG. Someone's not muted. Okay, now see, we're beginning to use some of the things we practiced tonight. These are added. So I'm going to reduce this and put it going from expanded form back down to the other form would be x times x plus 15. Remember, if I break it back down into contracted form, I'm multiplying these log numbers. All right, so you're putting it in contracted form. And because they were added, I multiplied the bases. That's that rule. So now I have log x squared plus 15x if I want to do that. That's my log number. So I need to put my base in. My base is 10 because I'm going to change to the exponent form. So when I do
Can you
that,
explain how you get that?
how I got 10?
No, the x squared. Where did the x squared come from?
I
That part.
distributed that.
Oh, duh. Okay. Sorry. Thank you.
Sorry, I should have said that.
I see it. I see it now. Thanks.
All right, so I'm going to do 10 to the 2. Remember that little circle thing we do? Equals x squared plus 15x. And I'll be if we don't have a quadratic equation. Goes back to our quadratic life. So this is going to be 100. Subtract 100 from both sides. And set it equal to 0 like we did in our long ago quadratic life. Then you're going to factor this. It's a simple quadratic, so let's see. Got to subtract factors of 100 to get 15.
5 and 10.
Oh, 5 and 10 won't get 100. 5 times 10 is 50.
I was looking at a different problem, I'm sorry.
Oh, it's okay.
25,
What is it?
20 and 5.
20 and 5 ought to work. 20 is going to be positive, 5 is going to be negative. So we set each one of those equal to 0. This one gives me x equals negative 20 when I subtract the 20 from both sides. This one gives me x equals 5. Okay, now I'm going to wait till you get there because this means something special. Okay, my answer is only 5 because this is called an extraneous root.
Oh, yeah, because it can't be negative.
You can't have a negative log number. Good, you remembered. You can't have a negative log number. And see, if I put 20 back up here where this x is, that negative 20, I put it back there where that x is, that's going to make that negative 20 right there. It's also going to make this one negative 5. So you can't have a negative log number. The big log number can't be negative. So this is an extraneous root. You can't use it in the problem. So your only answer is x equals 5. Okie dokie. All right, do we have final questions before those of you that go away, that want to not see the rest of this?
I've
What
done
I'm-
this myself all up trying to do homework at the same time.
What I'm going to do for those of you that want to stay is I'm going to start back with 8 and work from 8, 9, 10, 11, and 12. And then I'll finish it if we have time before 8:30.
I just needed to know what, I was doing number 11. I just need to see the bottom part of number 11.
The bottom part of
5.
number 11. Okay.
Yeah, when we were working it, I just didn't want to hold up everyone, so
Oh, we didn't do 11, did we?
I think we did. It was the one where it was the square root one.
Oh, it was this one on the other assignment. This one?
Right, yeah.
Okay,
I'm
where
almost
did you get
finished.
stuck?
I was copying it,
Oh,
but
you
I
were
just,
copying it.
yeah, I didn't. Let's see.
While she's doing that, do I have any other questions? Billy, how are you doing? Are you okay? Brooke, Chandra, Amanda, anybody?
I don't know. I'll let you know when I start homework.
Okay. Corey, you good?
I got a small question, but it's really technical. Like when I'm trying to put in the stuff that it's asking me to graph when I was trying to start 9.3, it like I would get it exactly like it had it, and then it would like not count it. So I don't know, maybe I'm a little bit off,
No,
and I don't want to.
Twyla, we did that at the very beginning of class when you were driving home. Can you
Okay.
stay on a few minutes, and after I work these, I'll show you how to do that?
Okay.
You stay on?
Yeah.
Okay, I'll show you in just a
Okay,
minute.
I'm finished with that.
Okay. All right, let's start with 8. For those of you that still want to stay. Number 8 is e to the negative 0.71 t equals 0.94. And of course, I'm going to have to log both sides, but because it's e, I'm going to do the ln. ln e negative 0.71 t equals ln 0.94. Then I'm going to do the same thing. I'm going to bring this to the front. And I'll have negative 0.71 T ln E equals ln 0.94. Now, someone remind me, what is ln E? Every time I see that, what is that going to be?
1.
1.
That's 1. So 1 times this is just going to be this. So now I can do 7,1 and divide it out by both sides. Now notice it's not the ln of 7,1, it's just the number 7,1. So I put this in my calculator and I do ln and put 0.94 in there. And I'm dividing by, and notice it's not the ln of that. There's no ln over here. We cancel that out. It's negative 0.71. So when I get that answer, I get an answer of 0.0871 when I round it. It's a 4 behind it, so it doesn't round up. Okay. Number 9, you have 6 to the x equals 2 to the x plus 1. This is kind of a special one right here. I'm going to log both sides. And then I'm going to bring these exponents in front. Now, the interesting part about this one is it has an exponent of x plus 1. So I am going to distribute that thing in a minute. So what happens is I'm going to end up distributing that times that log 2. So I'll have x log 2 plus 1 log 2. Okay, everybody okay with that? Okay, now then, this has an x and this has an x, so I need to get those on the same side. I'm going to have x log 6 minus x log 2 when I subtract this x log 2 from both sides. And over here, this doesn't have an x on it, so it's just a number, 1 log 2. Okay, now watch. This is pretty tricky here. Those both have an x's in them. I'm going to factor out that x. And I'll have that.
Do they cancel the x log 2 minus the x log 2
Where?
on the right-hand side?
Yeah,
Right above
these
that.
two canceled.
Okay.
I actually just brought it from here over here because it had the x on it. But to do it, I had to subtract it from both sides.
Okay.
Okay, now then, if I can figure this out in my calculator, I will have the answer without having to put very long numbers in there. So let's see what we want to do. We want to put in log 2 on the top. And we're going to divide it by, and this group down here needs to be in a bigger parentheses. So I'm going to start a parentheses, and I'm going to say log 6, and I'll have to close the parentheses on that 6, minus log 2, and I'll have to close that parentheses on that 2, and then I'll have to close the parentheses for my denominator. So then when I hit the button, I get 0.6309. It's nice if you don't have to put anything in your calculator till the kind of the last step. Otherwise, you get all kinds of big, long numbers in all these places. We could have done it from, anywhere in here. We could have put those numbers in the calculator and gotten great big, long decimal numbers. But it's easier and better if you'll just keep them in the log form until the end, and then you can put all of it in your calculator.
I got a question. I'm trying to figure out what I did wrong. Okay, so I did the x log 6 minus x log 2
Mhm.
equals 1 log 2. And then I put the log 6 under the
Did you
log
take
6
the
minus,
X out?
yes, I did.
Okay, take the X out. So you have log 6 minus log 2.
Right.
Okay, then what?
Well, I put, the same thing at the bottom. And so
Right.
those
That's going to
cancel
cancel
out,
that.
right? And then it's just going to be an X. So I'm trying to figure if I put it in there wrong in the calculator. So
Okay, the only thing that I can think of you might have done wrong is that you've got to start this bottom with a parenthesis. So it's going to be a parentheses here, and then this one makes its own little parentheses for you. Minus log, and this one makes its own little parentheses for you.
so I'm just doing 1 log, then it's 2 parentheses, close parentheses. Then under that, I'm doing
Did you put
log,
divided by?
yes, that I meant to say divided
Okay.
by 6 parentheses.
Did you put log 6?
Yes,
Did you start your bottom with a parentheses?
no, so I need to start my bottom with
Yes.
parentheses.
And the
Okay,
reason you have to is because this is a group down here. See, it's got 2 parts. If you don't start this with a parentheses, it'll only take your log 2 and divide it by log 6. It won't do this. So you have to tell the calculator that all of this goes in the bottom too by using an extra parentheses.
okay, I got it now.
Okay, all right. Good deal. Okay, let's see, that's 9. Number 10. How are y'all doing? Okay. Is it
I'm
getting
alive.
easier?
I'm alive.
Okay. So this one is in log form and they want you to change it to exponential form. Can anybody tell me how do I do that?
I'm digging through my notes.
Okay.
The power rule.
Well, you want to change it to exponential form. So it's that little rule that says 5 to the 4th equals x when you take it out of logs. The little bitty number to the answer is the big log number. So then you just figure out what 5 to the 4th is, and this one's probably the easiest problem on the whole assignment. This one is the same way. You have to know that your base here is 10. So it would be 10 to the negative 6 equals x. And 10 to the negative 6 in the calculator is 1, 2, 3, 4, 5 zeros after that decimal and a 1.
These seem like trick questions because they're so easy.
Uh-huh. Yeah, after we've done those others, these are easier ones. Okay, this, when it starts out with a log, you want to change it to exponential. It starts out with exponential, you're changing it to logs. So this is 2 to the third equals 4x minus 7. 2 to the third is 8. Add 7 to both sides. We would get 15 equals 4x. So 15 fourths equals x. And they changed this one to 3.75. I wonder if they'll count it if you put 15 fourths. Okay, 13 is the one we did. So let's do number 14. You have log 4 of c plus 16 minus log base 4 of c plus 7 equals log base 4 of c. This is a subtraction, so you can write this log base 4 of c plus 16 over c plus 7 equals log base 4 of c. And if the logs are the same, you can cancel the logs. See, these are the same on both sides. You can cancel it out, and you'll just have a c plus 16 over c plus 7 equals c, and you can put c over 1 if you want to. Now, this is a proportion, so you can cross multiply. 1 times c plus 16 is c plus 16. And on this side, we're going to have a c times c plus 7. That's called proportion. To solve a proportion, you're cross multiplying. Some of you probably remember doing that. So let's see what we have here. We have c squared plus 7c. Subtract off your c and subtract off your 16. And you have 0 equals c squared plus 6c minus 16. C plus 8, c minus 2. So c plus 8 equal to 0 would give me c is negative 8, and I bet I can't use it. Plus 2 and plus 2 would give you c equals to 2. So if I put a negative 8 in this one, I'd have a positive 8, so that's okay. But if I put a negative 8 here, I'd have a negative 1. That's going to make a negative log number. And if I put a negative here, I'd have a negative log number. So this one's an extraneous root, so my only answer is c equals 2.
I feel better after seeing that one. I got myself confused when I tried to do too much at once a while ago, so that's better.
Okay, good. Anyone need to see more of this one, or wait a minute before I do the next one? We'll do a couple more.
I appreciate you, Ms. Sullivan. I'll see you on Tuesday.
Okay. All right.
Good night, everyone.
Good night. Okay, Shaquela, let's talk about your issue with the problem there. I'm going to go to where you're talking about and show you what you did wrong. I'm going to share my screen. And you tell me if you can't see it, okay?
Okay.
It should be going to our assignment
Yes.
4.4. Although
Mhm.
I'm gonna go to 9.3. Here's 9.3.
Okay.
Okay. I'm gonna go back to that number. I think it was 7.
Yes, it was number 7 that it started on.
Let's go back to number 7. We get this overview here and go to 7. Okay, this is number 7. I'm going to ask for a similar question. And it gives me this graph and it tells me to do all this stuff. Well, first of all, it gives me 2 to the x minus 3. Do you see that? Can you see my paper here too at the same time or not? Can you see this?
I can see the paper. The paper just small and the share screen big, so.
All right, this minus 3 on the end is a shift, but it's inside like a parenthesis, so it's going to be a left or right shift, and it's opposite of what you think. So if it's negative 3, it's going to shift actually to the right 3. Okay? So that's what I'm looking for. The basic graph is 2 to the x. So I have to fill that in there. I've got to find the one that says it's going to shift to the right 3 units. So that's this one right here, this third one down. But I have to click on this little button right here and put in that 2. That will give it the basic graph, 2 to the x. Then we're going to shift it right 3. So I'm going to check that answer and see if it's right. Well, that's what it's supposed to do. Now then I go to the graph. And this is the part that everybody messed up on, not just you. You're picking on every one of these until we do the logarithmic ones. You're picking this exponential one, which is this one in the middle on the bottom. And when you do that, come over here and always click on this 0, 1, because all of these will have this regular function that looks like this until you shift it. So click on the button and come over here to 0, 1 and click, and it'll give you a general shape of an exponential function. Then you come down here to these little things. It'll pop up this little gray square. Did you see that gray square when you did it? Well, these first one are stretches and shrinks. That only happens if there is a number in front of the x that's tiny, like 2x minus 3 or negative 4x minus 3. So we won't have anything to do with these first two at all. But ours was a horizontal shift, and it's opposite of what we think. So this one is negative 3, so we're going to come over here to positive 3. And I'm going to put that horizontal shift at positive 3. See how it shifted my graph over? Now, probably what you didn't do was down here, it says base, and E is already written in there. You have to put the base in. The base for this one is 2. So you put the 2 in. Now then, when you put the 2 in and save it, it will make the curve look like it's supposed to look. It looks almost exactly like the E curve, except when you get up in here, the numbers are different. So if you check your answer there, then it'll probably be good. Now let's go to the next one, and let me show you what happens.
Okay, because I need to know how to flip it the opposite way.
Okay. Let's do this one. This is 5 to the x plus 3. So we've already picked it. Looks like I already have a graph. I need a similar question. So this is a 5 to the x plus 2. Describe how the graph can be obtained from the graph. So we click on this. We go to exponential. We come over here to 0, 1, and you click, and it'll make that exponential in there, and it'll pop this gray thing up. I don't want either of these first two. Mine has a +2 on the outside. What is that going to do?
We're gonna shift it to the left.
No, it's not up with the X. It's outside.
Oh, it's gonna go up to.
Up to.
I mean, down. Is it up to?
No, it's if it's outside, you don't change the sign.
Okay, so it is up to.
It's only if it's little bitty up here with the X that you change the sign.
Okay.
So you don't change the sign out here. So you want a vertical one. That's a vertical one. So you go here to +2. Sometimes it's hard to get on it. Okay. Then if you don't put this base in there, it won't do it right. My base on this one is what?
The base, I can't see. Oh, let me see. 5x.
5. It's just the number 5.
Just 5. Okay.
Put that 5 down there, you won't get the right graph.
Okay.
And when you save it, it gets you the right answer.
Okay. So I click on that thing that says click to graph over here. I'm supposed to click on that. I don't just enlarge the graph, right?
Yeah, you can do that. All right, let's go to another one. One that has
Okay.
negatives on it. Let me find one of those. Here's one with a negative. See, this one's got a negative. I'll write it down for you.
Okay.
It says f of x equals 2 minus x minus x. All right, so see how this minus is in front of this x and it's up here in the little bitty part? This is going to reflect across the y-axis. That's what that minus in front of the little x does. Across the y-axis. This 2 that's up there with that x and it's little bitty is a horizontal shift, and it's opposite of what you think. So instead of being +2, it'll be a -2, or I go to the left. 2.
Okay.
And this one out here is an up 2 because it's +2 on the outside. See that? It's +2 on the outside, so that's up 2. So now I click on the graph. I click this one in the middle on the bottom. I come over to 0, 1, and I put a click, and it's going to pop this up. So I'm not going to do anything with the first 2. My vertical shift is my up. So I'm going up +2. I move it over to +2. My horizontal shift is this 2 that's right here with this x. It's the little bitty 2. And it's opposite of what you think. It's +2 because you use the sign in front of it, not the sign after it. +2. So I'm going to go -2 on the horizontal one. It's opposite of what you think. And then these are reflections. These 2 little boxes right here are reflect. And I've got a minus in front of my x. So that's going to reflect across the y-axis. So I've got to click this one that says reflect across the y-axis. Now then I've got to change my, well, I don't have to change my base. It's already at 2. But if it were not at 2, I'd have to change my base at 2. So then this is my picture that I save. And see, it says nice work. Then it gives me these choices, and I've got to go, all of these basic graphs are the same, 2 to the x. Then I've got to go left 2, left